So here I am live. I got to make sure I got this set up right. Still working on how to do all this live stuff. So we're gonna show using Circad to lay out a circuit board, and let me know if you can hear me. And let me know if the background noises or background music's too loud. I'll turn it down a little bit. There. Okay. So I'm going to show you guys how to do a circuit board layout in Circad. Waiting to confirm you guys are hearing audio. Can someone confirm that they can hear audio? I don't want to keep going if no one's hearing me. So this is the schematic we have. Your voice is extremely low volume. Okay, so let me go deal with that. Is that better? Check 1, 2. Move the mic a little bit closer. Okay, can you hear me? Is that any better? 1, 2. I'm going to switch out mics real quick. All right, switched out to 58. Is that any better? Check 1, 2. Can you hear me? Marginally. Okay, so I got to figure out what to do with my audio level. I've got it dimed here. Go back to OBS. Got it pretty much dimed there. Is this the audio you guys are hearing? Can you hear that tap? Or are you hearing it from somewhere else?
Where are you at?
I'm trying to do a Facebook Live video on how to lay out a circuit board, but my audio is not good. I'm trying to figure out how to fix it.
You can hear yourself, so should be fine.
I can't. No, they're saying they can barely hear me. Seemed like it was fine yesterday.
Nope, it is quiet.
All right, I'm gonna move the mic closer. A tiny bit more cutting with the 57. So I should go back to that. Okay. All right. Do a little bit of aiming here. Aim it closer to me. All right, we're gonna try that. How's that? Is that loud enough yet? I'm not sure how I can get it any louder. I've got it all the way up here. Let's go to settings, audio. I got it set up here. I'm going to go to my universal control. Check 1, 2. Why do I got a red line there? Oh, that's from plugging the mic in. Check 1, 2. I don't think that affects the feedback. No, I don't want that up. Check 1, 2. Oh, the 57 was the first. Yeah, I went to a 58. So did I say 57? I might have lied. All right, back to a 58. So more omnidirectional. So as I move, hopefully you'll hear me better. So yeah, hopefully once I get the setup tweaked in, there won't be so much of this screwing around trying to figure out the audio. Is that better? Okay, minimize that. Gotta leave that live. Go over here. Shallow the mic, maybe. What does shallow mean? I don't know that term. I need to get one of those desktop mics made for blogging or whatever. I think that'll help a lot. I thought I had ordered one and I hadn't. I forgot what I had actually ordered from Personas. I got the audio interface and I thought I ordered a mic, but I forgot. All right, somebody else says sounds fine. Okay, we're gonna just get started here then. So this is actually I'm gonna close this and start over. Give me a second here. So we're gonna open Circad, and you'll see right here, Circad is the world's greatest CAD package. I've been using this since the late 90s, probably. It's written by a guy from Davie, Florida. I think it says that somewhere on here. Well, it actually says Fort Lauderdale here. This is all hard-coded into his the code. Most of this was written in assembly language. Swallow. Oh, you want me to swallow the mic? Okay. Yeah, so most of this was written in assembly language until Windows, I think it was 8 came around. He had to start putting some video driver stuff in it. He was doing direct draw, which made it really fast. But then as the new Windows stuff didn't let you access video as well, he had to start using C code in order to be able to get into stuff. But it's still a great program. We are actually going to start being a distributor for this software tomorrow, I think. We worked out a great deal. It used to be $1,000 a seat. I think we have the price down to $295 a seat. I got to finalize the pricing with him, but we're trying to make it affordable, especially for the DIYers and the small builders. We want to get more people using the software because it is a great software. And at $295, that's pretty reasonable. And that's not a yearly fee. That's a $295 and you own it. In addition, we're going to start providing libraries of parts that we stock. So if we do work for you, we'll be able to give you libraries of what we stock. When you're doing a new design, you can pick parts we already stock. It simplifies the whole process. We don't have to stock a bunch of new parts because you didn't know what we already had. So anyway, there's a lot of stuff that this thing can do really well. Yes, and everybody hates Eagle. Oh, I hate Eagle. I don't know how many times I said that when I was talking to Fred. Fred's the guy who wrote Circad. I don't know how many times I told him the whole reason I want to distribute his software is because I hate Eagle and I want it gone. So this is highly keyboard based. So what that means is there's not a lot of there are drop-down menus, but you don't need to use them. I got to find my... There we go. I was hearing an echo of myself, so I got to get rid of that. Okay, so there are menus. I can do file and place, grab, all this stuff. I hardly ever use these. I use almost exclusively keyboard shortcuts. So I want to, for instance, open a file. So I hit F. And I want to open a file I worked on recently, so I hit T for Total Recall. That's a bunch of files I've worked on recently. And then I click on this. This is what we're working on. And it opens the schematic, and it opens the circuit board. So this is the schematic. It's a pretty generic drive pedal. We got a single op amp stage. We got input. Here's our clipping stage with a bass control, treble control right here, output level, power going to the op amp, your rail splitter, and this is based on a Mojo hand pedal. So we have basically the audio board is on top, and then we have a separate board that has the input output jack and the power supply, filtering and that kind of stuff. So that's not included here. I just picked something that was simple enough that we could do a whole layout pretty quickly. So I'll just show a couple things real quick about schematic capture, and then we'll go to the layout. The layout's probably what people are more interested in. But schematic wise, we're going to delete these lines, delete this pad. All right, and then I'm going to do PO, which means place a line. And I'm going to place a line between this dot, and then here and here. And I'm going to do PD to place a dot. A dot means connect those 2 points. So if I don't dot it, it may or may not be connected, depending on multiple factors. So if you want to be sure it's going to be connected, put the dot there. Yeah, I'll go into more of that in future lessons, but that's a quick rundown. So basically, you put the parts on the board, route all your traces, and then you need to tell the circuit board side what the part is. So we're going to do an edit component. We're going to bring this table up. So this is all the parts of the board. Order and reference designator. So pretty simple board. So all the caps, I'm using a C200, except for one electrolytic, which is an electrolytic, 100 lead space, 150 diameter case. The diodes are going to be a 400,000 space diode. Resistors are going to be 400,000 space resistors. The op amp's a DIP 8, and the pots are an RD90. So that's telling it all of the parts that we're going to have on this. I got to flip back over to my other page to make sure I'm not missing any comments here. Yes, Randy, I started a Patreon, and I'm going to start doing lessons where you have access for $5 a month. You can join my Patreon, and you have access to all the videos, or most of my video content. There's going to be some video content that are for the next level up, but the intro Patreon is $5 a month. You'll have access to these videos I'm going to be doing. For $20 a month, you'll be the next level, which is you'll have a classroom with 5 to 10, probably, maybe 20 at the most, I would think, other people, where we will once a month go over questions. So, and there'll be different levels of that, so that if you're an intro person, you'll be in a group with a bunch of other intro people. If you're someone who's intermediate or advanced, you'll be in different groups, and that way you can ask questions on the same level as other people. And that'll be an interactive on Zoom. And then there's a higher level where that's currently $50 a month, and these are numbers I'm just starting with. They'll probably change as time goes on, but the $50 a month is for more advanced people that want, more specific help. And so once a month I'll have a meeting with multiple, probably max it out at 5 people to maybe 10 in that group, where you can bring a specific design problem you have, and we can share your screen and we can talk about it as a group, trying to solve whatever problem you might have. So that's something that I'm in the middle of working on. So anyway, we have all these parts picked out, and we are ready to do the actual layout. So I'm going to do, NO to output the net list. So that's creating a net list of this schematic of the parts and all the connections. Alt-N gets me to the other screen. Now I'm going to do an NI to net list in, and it's going to make all the connections for me. Now we look at the summary screen, and the summary screen tells me whether or not there's any errors. So if there's errors, then we are going to try to fix what those errors might be, and again, we'll get into that stuff in a later lesson. But you could fix errors with, like, if it doesn't know what footprint it is, or if it can't find a specific pin because you call out a 16-pin part, or you called out an 8-pin part, but you told it there was a pin 10, things like that. But again, we'll deal with that later on. So what we've done is we've imported it, and you'll see here a bunch of yellow lines. So those yellow lines are telling us how everything is connected. So as I drag apart, it's going to show me where the connections are. So I can unravel things based on how they're connected. Okay. So what we start out by doing is putting the parts in. Now in this case, what I've done is we have a template that is of every given enclosure. So here's the template including the enclosure that we're going to use on this particular pedal. And I've already pre-put in the coordinates of where all the pots are going to be, just so we could make this quicker and easier. So I know that there's going to be a pot here. And I'm zooming in and out with the mouse scroll. All right, so I'm lining up these pots here and here. So now my pots are all placed. I have a connector that's the input to the board from the lower board, as we talked about earlier. And we're going to put that about here. So now we want to start putting our other parts in. So put the op amp in. I can grab one of these at a time, drag them up, and just put them about where they need to go. Or what I can do is a block copy, or a block, not copy, a block grab. So BG for block grab. Mark the block. And then you click one more time. The third click is where you're going to grab it from. So when I do block move, BM, for block move, it's going to move them from the point where I clicked. So what I'm going to do now is set those up here. And then BE will take that ring away, so the block will be flashing forever if you don't take it away. So BE is to get rid of the block. So now my parts are up near the board. So I want to start placing these in strategic positions. So let's just kind of start this out in the center. We already saw that this one wants to click in there. Now, if I want to see where things are connected to give me a good idea of where I might want parts, then I hit NH for net highlight. So I'm going to go over here, NH. So you'll see all of that stuff turned white, so there's nothing else going to that node. So let's go to the next node, or I got this part right here. So this part's going to connect there somewhere, so I have no idea where I want it, but I'm just going to randomly put it there. What I'm trying to do is slowly get everything in about the location that they're going to be, and then we're going to fine-tune them later. So this part here is a bypass cap for the op amp, so I'm going to put it by the op amp. So I have 9 volts in ground, so I want to put that somewhere near this op amp. We got the FX in, so this is the input from the 1/4 inch jack. So anything that ties to that, and you'll see it's all white, showing me where those nodes are. And those nodes are all now down over here. One of the cool things about this is, especially when you have dual monitors, in this case I'm only showing you one monitor, but if I hit Alt-N, I can go to the other pages that are open, and you'll see here FX in is highlighted white here and here. So everywhere that net is going to be highlighted. And it's highlighted here, so I can go back and forth and see what signal I'm looking at. All right, so now we're going to continue unraveling things. So this is a 9 volt connection. We're going to set that over here for now. That's part of our VREF circuit. This looks like, if I highlight this and I want to look at what it is, I go here and it's the output. So two things that I think about when I see this. This is the output, which means it's a buffered signal, which means it's not going to be sensitive to other signals. It could influence other signals, but it's not necessarily going to be sensitive to them. So I'm less concerned about how close parts are to the source here than I am with a input signal. For instance, over here, I want these parts close together and as close as possible to the op amp. Obviously, layout has a lot of things where you have to do things you don't necessarily want just because of physically where parts are. But this one I don't really care that much about. I care more about the stuff that's feeding this. So the reason I'm showing you that is because this part I know is going to the output pot. After here, I have a resistor, which is what's feeding it to the output pot. So what I would probably do, and we'll just start this right here and put this down here. So these are basically away from the op amp because it's a, like I said, a buffered signal, so it can travel halfway across the board without creating a problem. The next signal is the output. We're going to route that straight to there. So we know that one's good, this one's good. So basically we have the output where we want it. So now here's the input from that. That's that entire net. This is the other half of that control, and it goes down to this point here. So what I'm seeing here is pin 2 is going to be my clipping stuff. Pins 1 and 2 are going to be my clipping. So I have all these things that I need to get near there, including VR1 up here. So what I'm going to do is I'm going to take this op amp and I'm going to rotate it 180. And that's going to do a couple things for me. When I do that, obviously my other parts that I had already preset are on opposite sides, so I'll move them back. Again, we're just roughing it in at this point. So now as you see, this part that goes here and here, now I have it physically close to here. And I have this cap. And every time I move a part, I hit NR, which means re-rat nest. So when you move a component way over here, and you hit NR, it's going to reconnect the yellow lines to the closest net that matches it. So as you're cleaning out the layout and getting things physically where they need to be, the yellow lines get fewer and fewer and everything looks cleaner. So that goes across these two pins, as you can see. So this cap, typically, and let's go over here and see what that cap is. That's this 100 picofarad. So the purpose of this cap is for oscillation. That's trying to keep this stage from oscillating. Usually it will oscillate at a frequency you can't hear, hundreds of kilohertz, maybe 50 kilohertz. It'll be higher than you can hear, but the symptom will be you can't hear the output or the output level's too low. So this cap helps that oscillation not occur. So you want that as close to the op amp as possible. So I'm going to put it right here by the actual two pins it touches. Now I have this R7, this stuff's all scrunched, so I'm just going to randomly start moving stuff away like this. And I'm going to move this here. See how this is rat nested down to here and this is rat nested to here. When I hit NR, see, it simplifies it. So you can really tell whether you're cleaning it up as you re-rat's nest. So I know I got a bunch of other stuff going across. So let's start getting these in place. Did you guys hear the music in the background? It's my video game. I figured it'd be nice to have some background noise. All right. So I'm just going to place these, and I'm going to explain why I'm placing them. So I've got this node here. So I've got all of my 6 nodes here. This node goes from there to there, and then this node goes back over to here. Now, one thing you could do is if you want all your diodes to line up, you could potentially do this. So now all the diodes face the same way. I have one trace that goes there. I would have one trace that goes here, around here, and then it has to go up over there. And this trace has to then cross it. And so the reason I did it this other way is so that those traces don't have to cross. So we'll move forward with this for now. This resistor is going over to the pot. The other half of that pot goes back over to here. leads back to that. So we've got that routed. Now we're going to grab this part. This is so that's the base control. So we need to put that somewhere physically over by the base control. So let's move this over here like that. We want this node 5 and 1 to somehow get to each other. I'm going to put it right there. So that gets me from here to there. This I'd have to go down and inside the op amp to get there. I don't see a problem with that at the moment anyway. And then we have a couple more resistors and a cap. So let's just kind of move these over here and get an idea what we're trying to do here. So these two parts, we got a VREF going to pin 3, or node 3. So see these right here, these node numbers are the signal name, the netlist name. So that not only tells the schematic and circuit board what everything is, but when I'm looking for all the 3s as I'm routing things in my head. So, and the netlists are doing the same thing for me. But I know the 3 is this input to the op amp. That's going to be a sensitive signal. So we want to get that as close to the op amp as possible. So I'm going to put this one over here somewhere. I'm going to potentially put it right here. So then these signals are there. This is my VREF. I got another VREF here, see that? So if I look at all my VREF signals, they're all here. So I want to try to get these all close together. So I'm going to put those there. And I'm basically working this out as I go here. So once you're done, then you do it again. So this is what I'm calling the initial pass, and then I'm going to do another pass after the initial pass. Okay. So as you can see here, I've got things pretty well routed. This could be probably technically even done, but I mean I have to route traces. But what I will do is I'll continually retweak it as I route copper. So the next thing we're going to do is start routing copper. So the FX out I know. So we're going to do 0.025. So 25 thousandths is what I recommend. Now in Circad, to select layers, you hit L, and layer 7 is bottom copper. So you hit L7 to get to your top copper. L8 is your bottom copper. So I am running a 25 thousandths trace on a 25 thousandths grid. I highly recommend if you're doing a through-hole layout, use a 25 thousandths trace and a 25 thousandths grid. I see a lot of people using 5 thousandths or 8 thousandths or 12 thousandths traces. If you're doing a through-hole layout, there's no reason you can't use a 25 thousandths trace and a 25 thousandths grid. I don't think I've ever run into a through-hole layout where I have to go down to anything under 12. Every once in a while I have to go down to 12, but almost always you can get by with a 25 thousandths trace. So anyway, let's keep routing here. So as I hit NR, those yellow lines go away. So let's route here. And some of the routing I'm doing is rough just so I can start making the yellow lines go away. Now, 45 degrees are recommended in all board layouts. The original reason was in the corner here. I got to put my, there we go. Right here in this corner, when they used to etch the circuit boards, it had trouble with right angles. So this right angle here, they would have trouble etching that out. So they would recommend 45s, otherwise this wouldn't etch correctly. That's not as much of a problem with modern circuit board manufacturing, but it's still from a aesthetic standpoint, it's still recommended by most people. So I'm going to be kind of a little anal retentive here and line these up straight on top of each other. So I want to connect that to there, but see, I'm crossing the ground with 9 volts, so I don't want to do that. So I'm going to change layer by hitting L8, and I've just moved that to the bottom layer. And when I hit NR, those are now routed. So let's continue up over here. And what I would normally do is make sure I'm far enough away from the, when I'm going inside an IC, I want to make sure I'm far enough away that I'm not going to create a short problem there. Since this is through hole, I'm typically going to do bottom copper for almost all of the traces, and then only use top copper as I need or for ground. And that's again that's not a necessity, that's just how I've always done it. There's lots of opinions and lots of valid ways to do board layout. I'm doing something here, I'll explain it in a minute. If you're watching carefully, you might wonder why I didn't just put a trace right across there. There's a couple reasons. Reason number one is if I put a trace here and you're soldering the board and you're trying to troubleshoot it, that trace being there increases the chances of those 2 pins shorting, which is fine, but if you don't know that that trace is there, then you try to unshort it, and then when you're all done, you realize they were shorted anyway. The other reason is if you accidentally lay the board out with the pots backwards, and trust me, I've done it tens, if not hundreds of times, where I forget which view I'm looking at of the circuit board. Right now I'm looking at the circuit board from the top view, so I'm looking down at the top of the board. Sometimes I lay out a circuit board upside down. And if I forget that I'm doing it upside down, then I might make the pot work counterclockwise by accident. And so one way you can fix that when you're doing your prototypes is you have the traces not meet underneath here. Instead, they go on the outside. That way, if I need to cut one loose, if I need to cut this middle one loose and retie it to the pin 1 instead, I can do that without a whole lot of effort. So that's just a habit I have. All right, then we've got this right here. We're making good progress here. And I know that here's where I'm going to have some trouble. I got to figure out how to get that trace over. We'll deal with that one in a minute. And I got to deal with that one. So those are two we got to deal with. So let's get the rest of the stuff routed, and then we'll deal with those two guys. I like to line things up. Like, I don't like it when people do that. It just bugs me. So I like to line them up. Now, something to notice here, these black lines here are showing me where the little standoffs on the pot are, and those are metal on these particular pots. So if I'm doing top copper, I avoid these lines because I don't want those to sit on top of the copper, and then if the masking has a flaw in it, then you can short the trace to ground right there. So we're going to route VREF. All right, FX in looks like it's pretty safe to route. All right, this is a sensitive trace, so I want to try to get that there as simply as possible without getting in the way of anything. So this is where you start moving things around. So I'm seeing that R7 can move up here. R8, which I still got to deal with, I'm just going to move out of the way. This can move up. And then I can get this over there and this over there. GE means grab vertex. So that'll grab the corner of something. So I just dragged that thing from the corner, and that allowed me to get a corner from, so it was going from here straight down to here. By doing a GE, it said grab the vertex, and because it was attached, it lets me stretch it away and create another connection. You can also create another connection by doing PE, place vertex. So, all right, and I got ground here. GE, I'm going to do the same thing I did. So I grabbed it and it created a new one. I'm going to do PE. I'm going to do that, get my nice 45. So now I got to get this signal over to 3. Now, I do not like running traces under caps. That bothers me so much that I'm going to do this. I'm going to have to do this. There we go. Yeah, when you run traces under, oops, that's something I hadn't shown you yet, and I did it by accident. So if you have a trace on the bottom side and you go to the top side and you drag it, it's going to connect them. See that right there is called a via. So it's connecting the top to the bottom. And I'll show you that here in a minute where I use that. But what I meant to do is put a trace down here. Now we're just going to leave that here for now. And clean up this. PE gets me, grab the vertex. I can make that nice and neat. I need some ground. I got ground right here. Now, there's some flaws in this layout. We'll talk about them when I'm done here. So R8. Oops, I want to go to bottom. This needs to go to net 5. So in order to get that to net 5, I need to go inside. So what I'm going to do is move this whole thing down. And I use the keyboard a lot. I'm using the arrow. So when you grab a line, you can use your arrow keys to move lines around. And we need to get one more trace routed, which is this one right here. So I'm seeing a path through here, down through here, and I can't quite get there. So I got to start making ways to do that. So let's get it as far as we can and then see what happens. Actually, these can be bottom copper. And here's where I was telling you earlier about the changing layers. So I'm currently on this layer. I hit L5. I'm now on the top layer. And when I draw this and hit click, it's going to add a via and change my layer at the same time. And now those are connected. And it looks like it's completely routed. So let's find out. To find out, we do N and then plus for scan. It went through the whole thing. It did not complain. So that tells us a couple things. One, all the traces are routed. Number two, there are no shorts between nodes that aren't supposed to be shorted, and there are no clearance problems. So things aren't too close to each other. If I were to do, I got to change my grid so I can show you this. So if you see that, that's not shorted. But if I do a net scan, it's going to say there's a spacing clearing violation because these are too close together. So I'm going to undo that. So you set that stuff up here in the menu, set up parameters, and then your clearances. So these clearances are set for surface mount because I grabbed an old surface mount design and decided to do a through hole. So I changed all the parts to through hole to show you guys. So normally I have these larger for through hole. So a lot of people would be done at this point, and we could be done at this point, and it would probably work just fine. What I typically do is I get here and then I start looking, can I make this thing any better? So one thing I do is highlight my nets. So I look at where all my grounds are. Look at where my power is. Start looking at traces, where they're going, how far they're going. Are they going farther than they need to go? Move that text so it's not on top of the part. And the other things I would do is I would start creating more space between stuff. So these spacings are fine, but the more space you have, the more room for error. If you have etching errors, then having more space, if that etching error isn't going to cause your prototype not to work or your production board not to work. A note on through-hole parts, resistors and diodes. Let me show you my measurements here. I am spacing these 400 thousandths apart. I see a lot of people doing board layouts with resistors and diodes at 300,000 spacing. You can do it, but if you ever want to automate the process, you will not be able to. Equipment that auto lead forms components, like quarter watt resistors and diodes, those can only typically be bent at 400 thousandths. The bodies themselves are too large, so you cannot bend them at 300 thousandths with a machine. So if you're having somebody like me build this for you, and you have all your components at 300 thousandths, I'm going to no quote it, because if I have to build it, I have to hand bend every part just like you are, and I can't save you any money because I can't machine build it. So please, when you're doing a new layout, put all your components whenever possible at 400 thousandths. All right, so I'm going to delete that, and there's one thing that's bugging me, which is that's not at a 45. So let's just grab this item here, put it there. We're going to delete this extra line that's there. We're going to grab this, make sure it stays at a 45 there. So clean that up a little bit. So there you go. We've laid out a circuit board. I'm going to be doing more, and like I said earlier, there'll be more of these on my Patreon where you'll have access to more in-depth stuff. But this is a brief introduction of Circad and how to do a board layout. Thanks for watching. Oh, I should ask if there's questions. Is anybody still watching?